Namaskar and welcome once again to Pal Talk Statistics. I'm your host, Dr. Chinmoy Pal, bringing you meaningful insights into the world of data and analysis.
And I am Ria, your co-host. Today's topic is a very handy non-parametric test called the Kruskal-Wallis test. It's like the non-parametric cousin of ANOVA and very useful when your data doesn't behave normally.
Exactly. When you have three or more independent groups, but your data is not normally distributed, or it's ordinal in nature, the Kruskal-Wallis test becomes your go-to tool.
What is the Kruskal-Wallis test?
The Kruskal-Wallis test is a rank-based non-parametric test used to compare three or more independent groups to check whether at least one group differs significantly from the others in terms of distribution.
In other words, it's the non-parametric alternative to one-way ANOVA. But instead of comparing means, it compares the medians using ranked data.
When should you use it?
You should use the Kruskal-Wallis test when you have three or more independent groups, your data is ordinal or not normally distributed, the groups are independent of each other.
For example, suppose you're comparing customer satisfaction ratings on a scale of 1 to 5 across three different cities. Since the ratings are ordinal and may not be normally distributed, Kruskal-Wallis is a better choice than ANOVA.
How it works?
Simple. You combine all your data from the different groups, rank the values, and then calculate the sum of ranks for each group. Based on that, the test calculates an age statistic.
Then you compare the age statistic to a chi-square distribution with degrees of freedom equal to the number of groups minus 1.
If p-value is less than your significance level, usually 0.05, you reject the null hypothesis, which means that at least one group is different.
Real-life example.
Suppose a nutritionist wants to compare the effectiveness of three different diets on weight loss, but the weight loss data is skewed and non-normal.
In that case, she can run a Kruskal-Wallis test instead of ANOVA. If the result is significant, it means that at least one diet has a different effect on weight loss.
To find out which specific groups differ, she can follow up with a post hoc test like the done test.
Assumptions and limitations.
Like every test, Kruskal-Wallis also has some assumptions. Observations must be independent. The dependent variable should be ordinal or continuous. The groups must have similar shapes of distribution for the medians to be compared properly.
And one limitation, the Kruskal-Wallis test tells you if a difference exists, but not where. For that, you always need post hoc analysis.
Summary. Let's quickly recap. Kruskal-Wallis is a non-parametric alternative to one-way ANOVA. It compares three or more independent groups. It uses ranked data instead of raw values. Ideal when your data is non-normal or ordinal. Use post hoc tests to pinpoint which groups differ.
It's widely used in healthcare, social sciences, education research, and survey-based studies where the assumptions of ANOVA don't hold.
That's all for today's episode on the Kruskal-Wallis test. I hope it made this powerful non-parametric method clear and easy to understand.
If you found this episode useful, please follow Pal Talk Statistics and do share it with students, researchers, or anyone learning stats.
In our next episode, we'll dive into the Friedman test, which is a non-parametric test used for repeated measures. Sounds exciting, right? Both. Signing off. Stay curious. Stay statistical.